Unusual seismic activity has been intensifying near multiple volcanic regions, raising significant concerns among experts. The persistent earthquake swarms, particularly in the vicinity of Campi Flegrei, signal an alarming pattern. This is not a typical short-lived seismic episode. Rather, the activity has continued for an extended period, growing in both frequency and intensity. The most recent tremors include a magnitude 2.0 quake at a shallow depth, just one of many in a long series of events. What makes this situation particularly concerning is that only earthquakes above magnitude 1 are being recorded in the data, meaning there are undoubtedly many more smaller tremors occurring beneath the surface. Shallow earthquakes of this nature often indicate magma movement, and while such activity doesn't always lead to an eruption, it suggests increased volcanic unrest. The epicenters of these quakes are concentrated around the Solfatara area, where fumaroles continue to release steam, providing further evidence of underground activity. Given the densely populated surroundings, including Naples and its over 6 million residents, the potential consequences of an escalating volcanic crisis cannot be ignored. A closer examination of recent seismic records shows that the swarms have been occurring almost daily, with depths averaging between 3 to 4 kilometers, aligning with the known depth of the magma chamber beneath Campi Flegrei. The trend has been ongoing for weeks, with earthquakes ranging from magnitudes 1.8 to 2.6, consistently striking the same areas. Meanwhile, Santorini is experiencing its own unsettling activity, with indications of possible underwater volcanic unrest. Reports suggest that a significant event may have already occurred beneath the Aegean Sea. While some initially believed the tremors to be purely tectonic, new evidence suggests otherwise. Sounds resembling deep subterranean rumbling have been recorded, further fueling speculation that magma is on the move. In the dead of night, residents reported hearing unsettling rumbling sounds that echoed through the darkness. With no clear view of what was happening, only the tremors beneath their feet confirmed the reality of the seismic activity unfolding around them. The strongest earthquake in this relentless swarm registered at a magnitude of 2.6 at an exceptionally shallow depth of just 2 kilometers. This pattern of seismic unrest has persisted without pause, continuing into the early hours of February 15th. More than 130 earthquakes have already been recorded, many of which were felt due to their proximity to the surface. What makes this swarm particularly unusual is its duration and the consistency in magnitude. Unlike the escalation observed in Santorini, where seismic activity progressed from smaller tremors into more powerful quakes, these events remain within a relatively stable range, fluctuating between magnitudes 1.9 and 2.6. This raises a critical question. Is pressure accumulating beneath the surface? And if so, what does this mean for the stability of the region? Decades of research have shown that the crust in this area has weakened significantly since the 1980s. Studies indicate that it has lost 2/3 of its original strength, meaning that prolonged seismic activity poses an increased risk. The land here has been steadily rising, a phenomenon known as Bradyseism, further suggesting underlying geologic movement. Notably, the stronger earthquakes are occurring at slightly greater depths than the shallower ones, which are situated within the hydrothermal system of Campi Flegrei. This distinction raises concerns that deeper quakes could be linked to magma movement. A magma chamber was discovered just last year at a depth of 3.9 kilometers, a distance that is not far from the surface. If seismic activity is originating at deeper levels, it could indicate that magma is attempting to ascend, potentially creating pathways as it moves upward. The presence of fault lines and natural fractures in the crust provides a conduit for not only seismic stress, but also for volcanic fluids and gases to rise. Given that the region's caprock has become more brittle since the last major magma intrusion in the 1980s, there is potential for further fracturing. This could allow hot fluids, and eventually magma, to reach higher levels within the system. At the same time, land uplift in the area has been accelerating. For years, the ground has been rising at a steady rate of approximately 1 centimeter per month. However, in April of last year, that rate temporarily doubled to 2 centimeters per month before slightly decreasing again. With the current increase in seismic activity, the key concern now is whether this land uplift will continue to accelerate in tandem with the earthquakes. If the trend continues, it could signal a critical phase in the region's volcanic cycle, warranting close observation by scientists and authorities. Beneath the surface, something is steadily exerting pressure, causing the land to rise at a remarkable rate. Since 2005, the ground has lifted by approximately 142 centimeters, equivalent to the length of an exaggerated stride. This uplift is strongly linked to the presence of a shallow magma chamber, which was recently discovered to be filling from a deeper reservoir. Much like the processes observed in Iceland, where an inflating magma pocket pushes the crust upward like a balloon, the same phenomenon appears to be unfolding here. The critical question remains: is pressure continuing to build, and could this lead to an imminent eruption? While it may result in only a minor event, similar to recent phreatic eruptions in Ethiopia or Yellowstone, where steam and rock were explosively ejected, the risk cannot be ignored. Scientists monitoring the situation raised concerns over a year ago, with some even advocating for evacuations. Their warnings extended beyond the expectation of stronger earthquakes. They also emphasized the potential for an eruption, ranging from a minor venting of steam to a catastrophic scenario. The worst-case outcome would have global consequences, though even a small eruption could be devastating, given the dense population surrounding the caldera. The urgency of the situation cannot be overstated, as ongoing land deformation suggests continued underground activity. Meanwhile, other volcanic regions, such as Santorini and Ethiopia, are also showing signs of unrest. A magnitude 6.0 earthquake recently struck near Fala Volcano in Ethiopia, an area that has already exhibited steam emissions. Could magma be moving toward the surface there as well? Is an eruption quietly unfolding in Santorini, unnoticed? These are the pressing questions that demand close attention. Now, let's check the latest earthquake updates from across the world. The latest seismic activity has revealed a magnitude 1.4 earthquake within the oil fields of Texas, while ongoing seismic events continue in the Santorini region. Over the past few days, approximately 1,396 earthquakes have been recorded in this area, with a recent magnitude 2.8 event occurring along the northern edge of the earthquake cluster. More significant tremors have also been detected, including a magnitude 4.0 and a 4.7 earlier this morning. While activity appears to have slightly decreased in intensity, the overall seismic pattern suggests continued geological unrest. Seismographic data from the past 2 weeks indicate persistent fluctuations, with periods of heightened activity followed by brief lulls. The recorded depths of these earthquakes, averaging around 10 kilometers beneath the surface, suggest that the region is experiencing deep-seated pressurization, likely caused by an influx of magma from below. This buildup of pressure appears to be reaching a critical threshold, occurring approximately 6 to 7 miles beneath the surface. It remains uncertain whether the current lull signals a temporary pause before another surge of seismic activity or a more prolonged quiet period. However, given the nature of magma movement and the history of similar swarms, such as those observed in Iceland's continental rift zones, it is likely that the process is far from over. Unlike Iceland, which is dominated by rifting tectonic forces, the Santorini region is characterized by a network of submarine volcanoes, including the Colombo volcano and others extending northeastward. Recent seismic migration patterns have trended southward towards Santorini, suggesting a dynamic underground process that is still unfolding. While a temporary decrease in minor tremors has been observed, the sporadic occurrence of stronger earthquakes is a clear indication of ongoing subsurface pressurization. One key challenge in assessing the full scope of this activity is the limited availability of underwater monitoring stations. While a functioning seismograph station exists on the eastern edge of the Santorini volcano, there are no active GPS displacement measurements available for the Morges or Colombo volcano regions. Without these crucial data points, determining the precise extent of ground deformation remains difficult. Despite the uncertainty, the sheer magnitude and frequency of recent seismic events suggest that this is not a transient phenomenon. The ongoing fracturing within the swarm's core is a sign of significant underground swelling, hinting at a complex and evolving geological process that may lead to further activity in the near future. Recent data indicates significant geological adjustments in the region, with vertical displacement measurements showing a sharp increase over the past month. This surge in inflation, concentrated northeast of Santorini with occasional shifts southward toward the volcano, suggests ongoing subterranean swelling. The process appears to be driven by magma intrusion, though whether this will culminate in an imminent eruption or a temporary lull before renewed activity remains uncertain. The data, however, strongly supports continued inflation, highlighting the dynamic and evolving nature of the region's geophysical state. Despite a temporary decline in seismic activity, new tremors continue to emerge. A magnitude 3.6 earthquake was recently detected, aligning with patterns observed on seismographic records. This persistent seismicity, coupled with inflation trends, indicates that the region may be nearing a critical threshold of pressurization. The underlying rock layers, already under significant stress, may eventually fracture, facilitating magma movement toward the surface and leading to further earthquake activity. Observational data aligns with this interpretation, revealing a period of intense seismic swarming alongside measurable ground deformation. While no eruption warnings have been issued for Santorini or the Colombo volcano, the situation remains highly dynamic. Current monitoring stations offer limited coverage, making it challenging to obtain a comprehensive assessment of subsurface conditions. Nevertheless, inflation, earthquake swarms, and shifting fault activity suggest that the region remains in a heightened state of unrest. Globally, earthquake activity over the past 24 hours has been moderate, with the largest event, a magnitude 5.3, occurring in the South Sandwich Trench. Another magnitude 5.0 earthquake was recorded in the Banda Sea near the Indonesian islands. Seismic activity worldwide remains relatively moderate, with only minor shifts recorded in key regions. The area around Japan, which experienced movement yesterday, is notably quiet today, apart from a magnitude 5.0 event and a 4.3 earthquake off the coast of Russia earlier this morning. The usual clustering of seismic activity continues around the Indonesian islands, with a magnitude 5.0 recorded there. Meanwhile, the New Zealand-Fiji region appears unusually calm, with only a shallow 4.9 earthquake reported. In contrast, the Middle and South American trenches are displaying slightly more activity than the previous day, but only within the range of magnitudes typically expected for that region. On the U.S. West Coast, seismic activity remains within normal parameters. In Southern California, no significant tremors above magnitude 2.5 have been recorded, with only small-scale microseismic activity detected. Further north, a magnitude 2.7 earthquake occurred along the Hayward Fault in the San Francisco Bay Area, a fault system widely regarded as highly dangerous due to its potential for generating a major earthquake in a densely populated region. Additional minor quakes have been recorded in the vicinity, forming a distinct triangular pattern of seismicity. Northern California, which was more active the previous day with several magnitude 4.0 earthquakes, has since quieted down, with the latest reported event being a 3.1 magnitude tremor. In Nevada, a small earthquake swarm has been detected in the western region, likely a reflection of ongoing strain along the tectonic boundary. This includes several magnitude 3.0 tremors near the Sheldon contiguous area in northern Nevada. Yellowstone National Park remains largely undisturbed, with seismographic readings showing no significant earthquake activity. While some wind-related interference has been recorded, the region appears stable for the time being. Though overall seismic conditions are relatively quiet, these regions remain under continuous observation for any signs of increased activity. Seismic activity in Texas and Oklahoma continues to stir, with an increase in small tremors detected across the region. A notable earthquake was recorded far to the south, in an area characterized by a complex network of fault systems. Unlike the northern portion of the region, which is heavily developed with oil fields and fracking operations, this southern location does not appear to have any visible extraction sites based on satellite imagery. However, as one moves northward, numerous oil fields and industrial operations become evident, many of which have been altered or obscured over time due to weathering and landscape changes. The presence of these operations has long been associated with induced seismicity, and the earthquakes recorded in close proximity to these sites further highlight the ongoing seismic risk in the region. Texas, in particular, remains a hotspot for such activity, with earthquakes frequently appearing on the map. Meanwhile, a magnitude 2.4 earthquake was recorded near Jackson, Tennessee, earlier today. This event occurred just outside the New Madrid seismic zone, a region known for its history of catastrophic earthquakes. Over the past 30 days, approximately 23 earthquakes have been recorded in the New Madrid region, a frequency consistent with typical background seismic activity. These small tremors serve as a reminder that the fault system beneath this region remains active, capable of generating significant seismic events in the future. Hawaii also experienced a magnitude 3.0 earthquake off its northern coast at a depth of 14 miles. This event is likely linked to ongoing tectonic strain within the Pacific Plate rather than volcanic activity. Kilauea Volcano, which recently underwent a brief eruptive phase, has now entered another pause stage. According to the latest update from the Hawaiian Volcano Observatory, another eruption could occur within the next 3 to 6 days, continuing the pattern of inflation and deflation cycles observed over the past several months. Deformation data indicates a slight increase in inflation following the recent pause, suggesting that magma is once again accumulating beneath the summit. This cycle of repeated eruptions will likely persist until significant structural changes occur within the volcanic system, potentially leading to a shift in magma migration pathways. Turning to space weather, solar activity remains relatively subdued. Current observations indicate only weak sunspot regions, with no significant complexity that would suggest an imminent solar flare threat. A more active area is visible on the northeastern limb of the Sun, though its true nature remains unclear until it rotates further into view. The probability of an X-class solar flare remains below 1%, while the likelihood of an M-class flare sits at approximately 5%. No major geomagnetic storms are forecast, though a minor increase in solar wind speed has slightly amplified auroral conditions in polar regions. As always, continued monitoring is necessary, as space weather can shift rapidly with the emergence of new sunspot regions. As seismic activity intensifies beneath Campi Flegrei, the question remains, could this restless supervolcano be inching closer to an eruption? Scientists continue to monitor every tremor, every shift, and every sign that might reveal what's brewing beneath the surface. While no one can predict exactly when or if an eruption will occur, one thing is certain: the situation is evolving, and vigilance is key. What do you think? Are we witnessing the early warning signs of something bigger, or is this just another cycle in the volcano's long history? Let me know your thoughts in the comments below. And if you found this video insightful, don't forget to like, subscribe, and turn on notifications so you never miss an update on Earth's most mysterious and powerful forces. Stay safe, stay informed, and I'll see you in the next one.